Our experiment name is dielectric constant of ferroelectric crystal, and the group members included in this experiment are Anaparthi Samakka Potlaseri. Coming to the aim of this experiment is to study the temperature variation of dielectric constant for barium titanate, and also to determine its Curie temperature, and also to determine the value of Curie constant, and to verify Curie Weiss law for barium titanate. And coming to the operators required in this experiment are the probe arrangement of sample barium titanate, and also oven, and this is temperature control. We need to set the temperature using this temperature control, and this is the digital capacitance meter, and this whole thing is main unit of this experiment. And this is the oven, and now I'm going to tell how the sample was inserted. First of all, inside the oven again we have these two probes. From this oven part, one is connected to this temperature sensor and another one is connected to this capacitance sensor, where it will send the capacitance of the sample. Basically here we are using the barium titanate as our sample. So first of all we have to pull up this probe, and then we have aluminum foil. We will keep this aluminum foil first, then release the probe gently. After that, keep the barium titanate sample under one of this probe, then put it down inside gently, and probe leads are connected to the digital capacitance meter. Initially, oven is kept in off mode. At that time, we need to take the capacitance value at room temperature. After that, we need to switch on this oven. It means LED would light up and temperature would start rising. At that time, at different temperature, we need to take the corresponding capacitance value, and we need to plot the graph between dielectric constant versus temperature. From that we need to find the Curie temperature, and after that we need to plot the graph between reciprocal of dielectric constant and T minus Tc. So from that we need to verify the Curie Weiss law. This is all about the procedure.
The calculations of dielectric constant of ferroelectric crystal is as follows. The entire information which is required for the calculation purpose is already given in the procedure, in which the sample that we are considering is barium titanate, which consists of the radius 5.5 into 10 to the power of minus 3 meters, and the area is given by pi r square. By substituting the value of r square, we will be getting the value of area, and the thickness is also given. Coming to the calculations, we will be the tabular column is as follows. The temperature will be considering it in degrees Celsius. Corresponding increase in the temperature, we will be taking the capacitance of the values and calculating the dielectric constant. Initially, we will be taking the room temperature and calculating the capacitance. Thereafter, gradually increasing the temperature by 5 degrees. Now, as temperature is increasing, the capacitance values will also gradually increases, but at a particular value of temperatures, the capacitance value will be decreasing. As we can see here, at 130 degrees Celsius, the capacitance is 2235, and at 135 degrees Celsius, the capacitance is given by 2167, in which the capacitance start decreasing between 130 to 135. But as we don't know the exact value of Curie temperature in which the capacitance is reducing, we will be calculating the temperature and capacitance from 121 to 135. As you can see here, between 134 and 135 there is a drastic decrease in the capacitance. At 134 the capacitance is 2204, and at 135 degrees it is 2179, in which there is a decrease in capacitance. Based on these values, we will be calculating the Curie temperatures graph, in which we will be taking temperature on x-axis and dielectric constant and on y-axis, and plotting the Curie temperature of the given capacitance. By using this table, we will be calculating 1 by E into 10 to the power of minus 4 and actual temperature minus Curie temperature, in which by using that we will be plotting a graph in which on x-axis we will be taking T minus Tc, and along y-axis we will be taking 1 by E into 10 to the power of minus 4, in which the slope whatever we will be getting from this graph will be used as Curie constant by reciprocal, and that value will be used in calculations further. By using the Curie constant formula, C is equals to n square mu. By using the formula Curie's constant n mu square by 3 kb. We'll be calculating the dipole moment, which is which we got in this experiment as 2.09 into 10 to the power of minus 23.